All right, on the formula sheet for extension 1, these are the angle sum identities that you get. So we're going to make sure that we're able to write them all out. These, notice they're just plus, plus, plus. We have to be able to write out the negative version, the minus versions as well. So I'm going to do them. Do you want x's and y's or alphas and betas?
X and Y.
So therefore, sine of x plus y is sine x cos x plus cos x sine x. I always say, cos x sine x cos y plus cos x sine y. Sorry. I always say sine, see sine, keep the sign the same. The plus and the plus. That's how I remember it. Sine, keep the sign the same. So therefore, if you're doing the negative one, sine of x minus y, yes, we get the sine x cos y, but keep the sign the same. So for the sine one, it's keep the sign the same. Got it? Now the cos one. Well, if you're keeping the sign for if you keep the sign the same for sine, then you don't do it for cos. All right? So notice cos of x plus y, but this one's different too. It's cos cos, sine sine. So it's cos x cos y minus sine x sine y. Okay? So for cos, the sign is not kept the same. We've got x plus y, but here we've got a minus. So therefore, cos of x minus y is cos x cos y plus sine x sine y. So these are just our double, not our double, but our sums and differences of angles. Why is it called sums and differences? We're summing two angles here, and we're finding the difference between two angles there. Next one, tan of x plus y. Notice that the tan, you've got a plus here and there's a plus on the numerator, minus on the denominator. That's what we notice about that rule. So it's tan of x plus tan of y over 1 plus tan of x times tan of y. So we're noticing for this one that if there's a plus here in the x plus y, that there's a plus, that there's a plus on the numerator and a subtract or a minus on the denominator. And I'll just fix that. Tan of x minus y, therefore, is tan of x minus tan of y over 1 plus tan of x times tan of y. So when there's a minus here, there's a minus on the top and a plus down the bottom. We should be able to derive the double angle results from these. So if you look at the plus ones, and if that was x plus x, you'd have sine x cos x plus cos x sine x. Do you get it? Yeah. So two lots of the same thing. If that was x plus x, it would be sine x cos x plus cos x times sine x. So it's two lots of sine x cos x. So double angle results, I'm going to go theta this time. Sine 2 theta equals two lots of sine theta cos theta. Okay. Double angle result for cos. We'll look at your formula sheet actually. So double angle result for cos, coming up here. If these were both thetas, you'd have cos theta minus sine theta, which is cos squared theta minus sine squared theta. But there are two other results. Now, the way I remember it is, this is the cos double angle result. So you know how one of them's cos squared. So I remember it as being 2 cos squared theta minus 1. And the other cos 2 theta result, fantastic, is 1 minus 2 sine squared theta. Now, a lot of people get confused about which one's which. So we know that these two exist, but how do you know if it's 1 minus 2 sine squared theta or 1 minus 2 cos squared theta? I say to myself, this is the double angle result for the cos. So the cos one's the one that's got the positive cos. And the sine one, the sine squared has the minus in front of it because it's the cos 2 theta result. And the tan 2 theta result, looking at the tan results up there, if we were to double it, you'd have tan theta plus theta is tan theta plus tan theta is 2 tan theta over 1 minus tan theta times tan theta, which would be tan squared theta. So that double angle result is 2 tan theta over 1 minus tan squared theta. Now, you can also, while we're here, we're going to look at the half angle results because they are really the double angle results, but everything's halved. Now, for half angle results, they are really double angle results, but what happens is they look like half angle results. Just with the double angle results, you'll notice you've got double angles on the left and single angles on the right, or in other words, the angle on the left is double the size of the angle on the right. So if I write sine theta, but I keep this result the same, as long as this theta out the front is double the size of these ones here, sine theta would be 2 sine theta on 2 cos theta on 2. That is a half angle result, but it's actually based on the double angle results. Okay, if I replace the cos 2 theta, as long as the 2 theta is double what's here on the right hand side, cos theta really is cos squared theta on 2 minus sine squared theta on 2. Do you see that? I'm following the same result. Cos of theta is also 2 cos squared theta over 2 minus 1. As long as the angle out the front is double the one on the right. This is double that. The other cos theta result is 1 minus 2 sine squared theta over 2. And the half angle result for tan, and the reason they're called half angle results is because all the angles on the right are halved. They're half angles, they're theta on 2's. Tan theta is 2 tan theta over 2 over 1 minus tan squared theta on 2. So these are our half angle results.